ocean in the night. Blonde waves, cascading eyes like distant fires. Ample curves and legs that steal the light. She turned down the stage, the hall of it fame. Chose the shadows, hands that heal the pain. Private masseuse in this corporate game, soothing souls on the edge of insane. Oh, the secrets they whisper in the dim lit room. Power brokers crumbling under her touch. Men and women chase her like a fleeting moon, but she stays professional, never too much. Cursed by beauty, a soul unseen. They crave her body, ignore the dream. So many truths she could twist and scheme. Blackmail, empire, shadow the regime. Sail away to the stars so far. By a ship with shadows, leave it all behind. Sail away under alien skies. Find a world where her heart can unwind. From e-board rooms to outlaw dens, clients bear their burdens, spill their sins. Fingers dance on skin, easing the tense, but advances come where the line thins. She pushes back, armor of grace, hides her purpose, her inner space. Years of whispers, a dangerous chase, power in silence etched on her face. Oh, the secrets they whisper in the dim lit room. Power brokers crumbling under her touch. Men and women chase her like a fleeting moon, but she stays professional, never too much. Cursed by beauty, a soul unseen. They crave her body, ignore the dream. So many truths she could twist and scheme. Blackmail, empire, shadow the regime. Sail away to the stars so far. By a ship with shadows, leave it all behind. Sail away under alien skies. Find a world where her heart can unwind. Now she's weary of the gilded cage, dreams of brokers in the black market haze. Sell the scandals, turn the page, pocket the creds, ignite the blaze. A small aurora, engines hum low, jump through gates where no one knows. Leave the lust the corporate throws to a system where true freedom grows. Sail away to the stars where her soul can stay. Sail away.
Good morning, everybody. Good morning, Owl Wolf. How you doing, buddy? So this is our conversation that we were working on with Grok, going through our education and refreshing of information on the stuff that I'm going to be doing for SpaceX. Yesterday's live stream, we went through that, that I believe we were at this last one right here, and we will continue on with our education. We finished reading this. We got all the way down to ultrafiltration, I believe. This is where we stopped. How do ultra-pure water systems work? The 6 stages, where I was explaining the stages, and if you guys need to get caught up, you can watch yesterday's live stream on ultra-pure water treatment training. Part 1. This is going to be part 2. I should rename that, actually. It's a good idea. Because I didn't name it as part 1, part 2. This one's listed part 1 or part 2, but let me just rename yesterday's live stream, edit, and list it as part 1 here. Part 1. There we go. Save. There we go. And then when this refreshes, it'll be part 1. All right. So we talked about the 6 stages of treatment sequence, pre-treatment, which actually we will do treatment before that because we are recirculating the water coming back from the line. So there will be pre-treatment after the pre-treatment. Reverse osmosis, electrodeionization, which we covered yesterday. Ultrafiltration. This removes particles greater than 0.01 micrometers and colloidal silica using 10,000 molecular weight membranes. So this we need to study up on. Then it goes through UV oxidization. That's the wavelength, the nanometer wavelength of the ultraviolet, and this reduces the total organic carbons even further to below 1 part per billion through organic compound breakdown. The ultraviolet breaks the cell walls of any kind of bacteria and such, and that's how you kill all the bacteria out. And then you polish that. You still have the dead bodies of the bacteria in there. They're dead, but there's still the cell walls, the plankton, or no, it's not going to be plankton probably, but you know what I mean, the little flagellum and all the little bacteria parts and stuff that's inside the bacteria. It's all still in the water. Though it's dead, you're not going to get sick, but we need to remove all of that because this is ultrafiltration, and we can't have even a dead cell wall left. So we have to then do a final polishing after that. 0.2 micrometer filters, membrane degasification. And so you're removing dissolved oxygen, dissolved carbon dioxide, any kind of bubbles in the water. You can't have bubbles in the water either. And non-regenerable ion exchange to achieve your 18.2 mega ohm per centimeter resistivity. That's the goal. The table below compares primary ultra pure water treatment technologies and their specific purification functions. So if you're going to reverse osmosis, this is what I made yesterday. This is the notepad. I started making notes, and they actually put it in the thing. So reverse osmosis removes your dissolved solids. I know what to say, dissolved solids removal. And you're going to have a 95 to 99% rejection. The EDI, electrodeionization, removes organics. Ion removal, I'll add that in there. Ion removal. And let me add in greater than 2 mega ohms per centimeter resistivity. All right. Then he goes through ultrafiltration. Look, this is just like the notes I made yesterday. This is awesome. And particle removal. Yep, particle removal. Look at me. Look at me doing all the old awesomeness. 0.01 micrometer filtration. I don't know how to make that that symbol with Notepad. And then UV oxidization does an organic removal, which is microorganisms. I'll just type in organic removal of microorganisms And this is to get the TOC below 1 part per billion. All right, so all of our notes are still solid. What are the key system components in this? Well, the key ultra pure water system components include the reverse osmosis here, EDI, which is electro deionization modules here, UV lamps. There's your, actually the UV is down here. Ultrafiltration, so they should have put it in the opposite order. They just made a list of how the process, and then they skipped, I don't know, anyway. It should be ultrafiltration membranes and then UV lamps. Actually, that's wrong. It goes through the EDI, then UIV, then, so this chart is wrong. This is correct. Continuous monitoring, I don't know why they did it 2 different ways. They should keep continuity in how they explain something. And continuous monitoring instruments that maintain semiconductor water quality specifications. Each element contributes to achieve the controlling resistivity, total organic carbons, particle counts, and silica levels across the treatment train. So the RO membrane, the reverse osmosis, uses a thin film of, now it's going to explain what the actual, what's actually happening. How are these things made? What do they do? Instead of just broad categories of reverse osmosis, EDI, ultrafiltration, what are each of these? So the reverse osmosis uses a thin film of composite material operating typically at 300 to 400 pounds per square inch, high pressure, on the high pressure side, and provide 3 to 5 years of service life under controlled pre-treatment and cleaning conditions. That's if your system is running the way it's supposed to be, and you're cleaning them as you're supposed to be, and whatever. So yeah, you don't want to have a big fouling situation, something go bad in your plant, and then now you have to change out the RO membranes. They should have lasted you 3 years, not 3 weeks. If you're rechanging them more than this, 3 to 5 years, you're wasting. And you need to figure out what's wrong with your system and fix it, because you're wasting a lot of money on RO membranes if you're replacing them weekly. If something keeps going wrong in your plant, you're just burning money. You need to fix that now. EDI modules use a thin cell voltage-driven ion removal, which is very cool. There will be videos later on that we'll watch where you put a direct current positive on this side, a negative direct current on this side, and the negative side starts pulling the positive ions like calcium, magnesium, and the positive side starts pulling the negative charged ions. So it's like a water softener in a way, but you're using direct current. Oh, I forgot to send out my notifications that I went live. Because Rumble, I will repeat this every time I do a live stream, Rumble doesn't work. Rumble's supposed to send out notifications to everybody, and it does not. So I have to manually send text messages out to all my friends to say, hey, I'm doing a live stream, because Rumble isn't sending you your notification to your phone. Very frustrating working with a subpar platform. I mean, like lowest quality, like whatever. It's like there's a minimum standard, and Rumble's not even close to achieving the minimum standard yet. I mean, I hope they will someday, but they're not even close right now. And then one more. So I send about eight or nine of these text messages out every time I start a live stream so that people will know. And then I only get 8 or 9. I've got 4,000 people following my channel, but nobody gets told that I went live. Thanks, Rumble. Thanks for making this so much easier. I want to X. At Rumble. At Rumble. At Rick. At Chris. 4,000 plus followers on Rumble. And when I go live, none of them get the announcement that I went live. I have to personally text message all I can to let them know I am live streaming. Can't very well meet. All right, it's good enough. I want to insult them, but I'm out of text. Frustrating. Whoa, why did it scroll down? All right, back to where we were. All right, so RO membranes, UV monitoring. So this is where we left off talking. EDI modules use thin, high voltage. Yeah, I was talking about the direct current, positive and negatives. And we'll watch videos on that in another lesson or later on in this lesson. And so you can see all of what that's about. In a chemical-free configuration to polish the RO permeate. So what comes out of the RO, this permeate means the good stuff that came out. It's a weird word, right? But what the purest water that can come out of the RO then goes through these. And this uses the direct current, positive and negative charges on opposite sides, and sustains a high resistivity output continuously. The UV lamps operate on dual wavelengths. A smaller wave, or actually, I guess bigger, and if it's in nanometers, or I guess smaller, 185 nanometers, and a higher frequency, 254 nanometers, with service lives around 9,000 to 12,000 hours. So those UV lamps will last a long time. Now you have to take them out and clean them. They will start to fall like a small film. The UV is in the middle of it, like a glass tube, or it's not. Anyway, and that tube will slowly start to get a little bit dirty or a little bit milky coating, and so you have to take it out of surface and clean those. Sometimes with acid, sometimes with this super micro cloth, kind of a thing. And then because if it starts to get cloudy, the UV doesn't shoot out into the water properly and break everything down. It starts to like get hindered. It can't go through as easy and go straight out and kill all the bacteria and everything. It gets like blocked a little bit, and so it's not as effective. Super clean, 100% effective. Goo. And then it starts to get a little bit of a sheen or a covering or a coating or just the smallest little amount. And now you're at 90%. Now you're at 80%. Now you're like, okay, our quality at the other end starting to go down. Let's check our tubes, see if they need cleaned. Oh, so there's ways to measure that. But that's one of what you have to, you're not going to get 12,000 hours out of the UV tubes without cleaning them. That is the UV light source will slowly start to degrade at 9,000 to 12,000. But to maintain proper treatment, you still need to clean. Supporting continuous TOC reduction and ultra pure water systems. Monitoring instruments include inline resistivity meters. So yeah, all along the process, you're measuring what's the quality of the water. What when it comes out of the RO, what is it? When it comes out of the EDI, what is it? When it comes out of the UV, what is it? When it goes in, you know what I mean? So you want to see like, okay, this is starting to have a problem. Let's look at that. What's the problem there? And that's another thing that we're going to be implementing is redundancy. So we've got two ROs, right? That's running on this RO. This one starts to have a problem, starts to go down, start to give not as good of a product. Well, we don't want to just fiddle and figure it out. Just shut it off and turn on the other one that's brand new and ready to go. And then figure this out, clean it, do maintenance on it, have it ready. Now it's ready. So when this one starts to fall out and have a problem, turn this one on, shut this one off. Don't risk lower quality going further into the system. And then it goes to the EDI. Have an EDI system and an EDI system. When this one starts to go bad, shut it down, turn on the good one. And then clean it, do maintenance on it, figure it all out, boom, have it be ready. The same next UV lamps. You want a redundancy that you can go this way or you can go this way. You always keep that flow going. You never shut down the factory. And they don't have that right now. They've just got some big tanks in the end. They fill it up. And if something goes wrong, they hope to have it fixed before those tanks are drained down all the way and they run out, and then they had to shut the factory down. Not cool. You need to make sure there's redundancy, even if it's twice as much money to make a factory this way than to make the ultra pure water. But you will never have to shut the factory down because of my job. My job, you have to invest the money so that I can do my job and make sure you never run out of ultra pure water. So that there's going to be a lot of, they're already starting, and there's not a big enough footprint at the facilities, so they're starting to build up. It's like a 30-foot, 40-foot ceiling in there, but they're only using 12 feet, 16, 20 feet. So they're starting to be like, all right, and then we're just going to pump it up. So now there's a redundancy is going to be up the upper one and the lower one, which is totally fine. I mean, you're going to have some different pressure differentials and things, but once those get locked in and you know what they are, then you're good to go. I mean, instead of say a 40 psi and a 60 psi with a 20 differential, you might have a 40 psi and an 80 or an 80 psi. Well, now you know you have a 60 differential, and then that's the new norm, and then you build off from that, But it's fine. It's totally going to work good. You just have to just gotta recalibrate everything. All right, monitoring instruments include inline resistivity meters, TOC analyzers, and particle counters that provide real-time quality data. So all the time, this is streaming data to the computer. You can watch it on trends. You can see that you're looking at a gauge or a meter or a number, and you're checking all these things. You just go look at the computer, and it's got all of the gauges, all of the trends. You can see which one is starting to go bad, and you can go right to that location to fix the problem. Controlling systems rely on PLC-based automation. That's just it's funny how I explain it, and then the next line talks about it. All right, so PLC-based automation with alarms and pressures, flows, and quality deviations. So the PLC, it's a term. What does PLC mean in water treatment computers? Programmable logic controller. So say you have a TOC meter, and you have, this is the minimum amount, or this is the highest. If it gets above this, we want an alarm. So you program it, and you go to the computer, and the computer's set to say, hey, if this level from this meter reaches this number, boop, 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 throw up an alarm, throw up a screen, throw up a whatever. Or if it reaches that number, even worse, shut it down. Shut that down. Shut that down. We don't want to burn up that pump. We don't want this water going in to this next part of the system because it's going to mess everything up. So your PLC, what is the freaking word? PLC, programmable logic control. It's just one of those terms that you never think about what it actually means because it's just an acronym you always use. That's why I hate acronyms. That's another thing that's cool about SpaceX. They say don't use acronyms. Like, if you do not use acronyms, because there's always there's a good chance of miscommunication. Like, say the Recovered Water Basin, RWB, at the water plant I used to work at. Then they could bring in another system for recycled something, and it's a completely different thing, but they would call that an RWB. So, hey, I'm going to go work on the RWB, and you're like, okay, you write it down in the logbook, and then something somewhere else in the plant starts shutting down, and you're like, what the hell? Oh, yeah, that's also called the RWB. It's stupid to have acronyms in these situations. And so SpaceX is like, you do not use acronyms. There's too much of a chance of miscommunication, and misunderstanding. Oh, I thought you meant that. You just don't do it. So the use of things like PLC, you say the whole stinking thing out, because then there is no misunderstanding. It's brilliant. But cities are just the people get so damn lazy. They're just like, I want to go to the CBPO and pick up my paperwork for my what is it? Temporary duties, TDA, because I'm going to go to the Well, what do you call the store? See, everything is acronyms, so you forget what things are even called. It's stupid. It's surface level ignorance. And you just get sucked into it because that's what everybody says. The last time I was at, they were just going, all right, the CLR2. Yeah, I'm putting water in CLR2. And you're like, what's CLR2? Oh, County Line Reservoir number 2. So I just started saying everything out loud. County Line Reservoir level 2, understood. And they're like, oh yeah. So then they started doing that. They're like, County Line Reservoir 2. And they start saying that. And they're like, yeah, that's actually a lot. There's like zero miscommunication. I mean, it's not CLR2. And you hear that fast. It might save you a little bit of time because you're stinking lazy and you think you're being efficient, but actually what you're doing is opening up this big gap of misunderstanding. You say County Line Reservoir 2. Everybody in the room knows exactly what you're doing. Anyway, I agree. Get rid of acronyms. And if you guys have been watching my live streams for years, you know I go off about acronyms. Anyway, all right. What water quality specifications must be met? So for semiconductor, ultra pure water must meet resistivity greater. So the higher resistivity, the better. Now conductivity, the lower, the better. That's what I was explaining yesterday. Resistivity is one direction, conductivity is the other direction. So this is good for conductivity. This is good for resistivity. They're opposite kind of directions for the numbers. The bigger the number, resistivity, the better. The lower the number, conductivity, the better. Total organic TOC, total organic compound. That's why you'll also notice that I'm talking here. I say that what these things are, these acronyms, total organic compounds. The fact that they're using acronyms is just because they're lazy. Or they have like a certain character count that their editor is saying, oh, you can't use too many words, so just use acronyms. That's stupid too, but whatever. Well, you're not, what are you saving ink on a web page? You're not saving printing costs at the newspaper here, people. Actually say total organic compounds. Pain in the butt. Anyway, that's a pet peeve of mine. It's more than a pet peeve. You shouldn't do it. It's stupid. All right. Less than 1 part per billion. PBB. Part per billion. Say part per billion. Silica. Less than 0.3. Part per billion. And particle counts of less than 1 milligram per liter. Why can't you type out milligram per liter? ml? Actually, this is M capital L. So I think this is microliters. In measurements, what is the difference between ml and ml? Milliliters. And the capital L is internationally recognized style in the United States, blah, 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 blah. What the heck? Just answer my question. Metric and imperial, centimeters, milliliters, 1/1000th. The difference is solely typograph and style. So in Europe, they put the capital L? No. Intentionally recognized. In the United States, organizations like this actually recommend M capital L. Oh, so they're changing shit. It's not microliter, it's a milliliter still. But it's like, hey, we've only been doing this for 120 years. Now let's start doing this because this new generation came up with a great idea. Frickin' retard. So now you grab a book that's 30 years old and everybody's like, what's that mean? What's that mean? That's another case of let's even screw up acronyms. We can't even say milliliter. We have to say ml. But now we're going to change that too. So, God, I hate humans. They're so stinking stupid. Can I just talk to computers, please? Because humans are just, everybody thinks that they're so smart. They're recreating the wheel. No, you're just creating confusion. There's absolutely no reason for, hey, let's make a capital L now. All right. And particle counts less than 1 milliliter. Well, let me ask you this. What is the difference between milliliter and microliter? A milliliter and a microliter are both metric units of volume. Okay. Milliliter equals 1,000th of a liter. Microliter equals 1,000,000th of a liter. Oh, okay. See this little U here? This little like a U with a little going down on the opposite side? That's microliter. Milliliter, microliter. And that's a millionth. So let me do this. Paint. All right, so where's my thing? Milliliter or microliter. That it's like this. That's a microliter. It used to be, whoops, microliter. But now they have to capitalize it, I guess. So maybe that's why they did it. Like, is that an I or is that an L? People becoming more computer oriented. They don't know if this is a 1. Is this an I? Is this an L? So now they're like, all right, this is now L. There's no confusion with, is it Michigan or is it milliliter? Okay, that kind of makes sense. If you're going to use an acronym, removing I mean, now that everything is computer oriented, a milliliter versus a Michigan, this could be an I, or it could be M1, like a factor of M1. And this is a variable times 1, or M2 variable or something. It could be a number, numerical value. But now that you make it a capital L, you've removed all. So they're trying, I guess that makes sense. They're trying to remove the confusion of their stupid acronyms. Rather than just get rid of acronyms and say microliter, just spell it all out. Zero confusion, microliter, or milligram per liter, microliter, yeah. Then they just say, okay, well, we don't want to spell it out. We're too damn lazy. We'll just make a capital L. That still annoys me. But I understand why you would need a net capital L now instead of just the lowercase l. At least I understand that now. Good job, Delnorin. You're learning. But it still annoys me. It's stupid. Why do it? Why not? Anyway, whatever. As defined by these standards and advanced chip production. Ooh, there. I want to look at that. What is the SEMIF 63 standard? I want to ask Grok about this one. Please explain to me what the is for and why it exists. Oh, semiconductor fab 63. 63 would be the 63rd rendition, printing, decision, convention, revision. The 63rd. So semiconductor fabrication 63. That's my guess. I don't know. I'm guessing here, people. Come on. Work with me. Boy, I got Grok thinking hard on this one. All right. A guide to ultra pure water used in semiconductor processing established by Semiconductor Equipment and Material International. So that's what it doesn't stand for semiconductor. It stands for it's another freaking acronym. Semiconductor Equipment and Materials International. They had a whole convention on that, I bet, about a 3-week convention in Prague or somewhere where they had like, all right, we want it to say semi. What can it's got to be semiconductor. Well, how EMI? Electromagnetic, no. Energetic, no. And then they take like 3 days deciding what the E is going to be. Just call it. It defines recommended quality targets, background guidance, and best practices for ultra-pure water systems semiconductor manufacturing. It serves as a practical reference document that helps companies, 1, Purchase and specify UPW equipment. It provides performance criteria so buyers know what purity levels, reliability, and compatibility to demand from the system vendor. So I want to order a pump. Well, does it meet the, I'm going to read this out. Does it meet the, dang, I got to scroll all the way up. Oh, there it is. Oh, does it meet the semiconductor equipment and material international F63 standards? So your vendor that sells the pump will say, "Oh no, that's not. That's for ultra pure water." They know. Oh, it wants this approval, you know. So we know that, oh, it's these groups of pumps that we can order because they're made for this kind of a system, ultra pure water system, semiconductor processing. If it's not in that, then that pump's probably not going to work. It's going to create micro cavitations, add air to the water, you know, this and that. So there's a reason why you want this classification on your equipment so that it works well with your system. Also, operates and controls ultra pure water systems. It gives guidance on process controls parameters, what to monitor and how tightly. So it's like, hey, make sure your resistivity is this. Make sure your RO is putting out this. Make sure your EDI is putting out this. It's just the standards that say you walk in and you don't know what you're doing. This gives you your guidelines. The semi F60. I want it. Can I get that? Amazon. I want to order it. I want to have it. Semi standard. Is there a book? Nope. Oh, here's like optical lenses for lasers for semiconductor plants. No way. That can't be. They wouldn't. All right. There's nothing. There's like nothing. That's it. And this is semi truck. That's what this is. These are semi trucks. F theta scan shield lens for Yeah, this is for ultraviolet lenses. That's funny. You can buy it on eBay. Yeah, these are the ultraviolet lenses. The 600. Oh, this is a 1064 nanometer. We were looking at like 124 and 256 or something. These are really high level. Oh, here we go. The F160s. See, now these are different wavelengths. Oh, no, this is 1064 still. Oh, this is the size of the lenses or the dispersal, like how are they narrow beam or wide beam? So you can pick the one that matches what you're looking for. All right, anyway. And you set quality expectations. The water has actually reached the wafer processing tool. So yeah. So that's what the standard is for. The semi, which means Semiconductor Equipment and Materials International. I'm gonna read F63. I'm gonna put that in my little note, my notepad of special notes. Semi F63. All right, cool. It covers a full range of contaminants, resistivity, total organic compounds. All right, F61 is a guideline. So it's not like the version, they cover different things. So an F61 covers design and operations of the semiconductor system. All right, I want to know this stuff. Where can I get copies? And the F75 is for quality monitoring. And the F63 is for purchase operations and expectation levels. So I need the F63, all right, I want to copy this stuff too. I want to get this info and know this info. There you go. I'm going to capitalize this. Semiconductor. So this one is used for I want to add this. Copy, notepad, put it into here. And it also does for purchasing, operate. All right, I want to put a space in here. And it's also used for setting quality standard expectations. And then these are the items. There we go. Whoops. So the F63 does this stuff. F61 is, I need to learn more about the F61 then. Semiconductor manufacturers use enormous volumes of water for wet process steps. They do, but they recycle it. So this, again, don't get all like, oh, no, you're destroying it. But no, we're not. We're reusing the water. It does use an enormous amount of water, but you use, and guess what? In your lifetime, you use an enormous amount of oxygen. Should we kill you? No, because you're expelling carbon dioxide. The plant uses it to make more. It's a recycling. Don't frickin' cry about how much water it uses. It's recycling all of the water. So this just sets these tree hugging retards off so bad. There's no reason for it. Because they don't understand. Oh, you're just gonna dump it down in the road. No, we're not dumping anything. Hey, my buddy Veenstra texted me. Oh, he sent me a dad joke of the day earlier. So cool. My buddy. My buddy. All right, so this was his dad joke of the day this morning. I have a pet termite. Doesn't everybody have a pet termite? All right, so I have a pet termite. He likes movies. So I named him Clint. Clint eats wood. Clint eats wood. My friend sucks. I hate you, Veenstra. All right, so semiconductor manufacturing uses an enormous amount of water for wet processing steps, especially rinsing the wafers after etching, cleaning, stripping, and other chemical processes. As transistor features have shrunk in size from hundreds of nanometers down to a few nanometers, the water must be extraordinarily pure. Even a few parts per billion or trillion of the wrong contaminant can cause defects, lower yields, and create reliability problems in the final chips. Doo-doo. Without extremely tight control of the ultra pure water, even the ultra pure water, UPW, ultra pure water quality. Just say the stinking word. Advanced chip production at today's technology nodes would be economically or technically impossible. Semi F63 exists because the industry needed a single consensus-based reference that everyone, chip makers, equipment suppliers, ultra pure water system builders, and testing labs could, so we're all talking the same language. Like all of these, the factories that make the pumps and the pipes and the valves and the sensors and the this and the chip makers and the builders and the testing labs and the testing equipment, all those people are like, well, now we all know that these are the ranges that we need our equipment to provide, the sensors to be able to read, the laboratory to be able to analyze. So now we're all on the same page. We all have the same expectations. That was the reason for the Semi 463. It was developed from input. So all of these industries met and decided, hey, we need to at least start on a foundation that we can all at least communicate with each other and have expectations. Otherwise, we're all wandering around doing our own thing, and it's very inefficient. And there's going to be miscommunication. I bought a pump. You thought at that. Oh, I didn't know that. And well, I didn't realize it was for ultra pure water. Well, now you know. I need the ultra pure water semi F63 stamp on this pump. So everybody's on the same page. So semiconductor manufacturers were involved in making this up. The International Roadmap for Devices and Systems, I don't trust that. I don't trust that. Ultra pure water equipment makers, the independent testing laboratories, and the technical committees. So, yeah, anyway. It is updated roughly every 2 years to stay aligned with advanced technology nodes. Currently, focus is the 32 nanometer and smaller process. Oh, well, we're going way below. We're going down below 7 in the 2 or 3 nanometers, I thought. Huh. With the most stringent requirements applying to leading edge logic and memory production. In short, it translates to extreme purity demands of modern semiconductors manufacturing into clear, actionable targets and guidance so the entire supply chain can design, build, buy, and operate ultra pure water systems that actually meet the needs of the fabrication facilities, says Fabs. That's just, again, it's basically another acronym. And I don't like it. Say fabrication facility. Anyway, key context. While Semi F63 is written specifically for semiconductor wafer fabrication, its principles and many of its requirements are relevant to any high purity water application in advanced electronics manufacturing and clean room environments. It is often referred to as ASTM D5127, which covers similar ground for electronics and semiconductors ultra pure water. The full document is available for purchase from the Semi store. It is not free. It contains detailed all right, where is the Semi store? Please give me the URL link for purchasing the Semi F63 F61 and F75 from the Semi source. I didn't know if you had a website or. All right, here we go. That's that one, and that one.
Hello, there are 7.
$380. I'm sure if they don't, I'm gonna mark this. Let me go to here. Can I add a tab? Just a sec. Add a folder. We're gonna call this semi. All right, cool. So if they don't have this, I'm gonna request that SpaceX buys these. Or maybe I'll end up having to spend $1,000 of my own money. So anyway, so bookmark, ultra pure water, choose Semi, save. All right, that's 63. Here's F61. And then here's F75. Oh, this is cheaper. All right, cool. So now my little bookmark where'd it go? Where's my, oh, it's inside of here. I'm gonna put this, can I, oh, I probably have to edit. Where is my bookmark? Here we go. Click. Oh, I guess I have to click it. Oh, manage bookmarks. There we go. So now here's my toolbar. I want to put Semi inside of this one. There we go. Now when I click on this, I have a folder inside where these are the Semi manuals. All right, so cool. That we didn't know, now we know. These 3 documents are designed to be used together. Yeah, exactly. You need all 3. You will need to create a Semi account to purchase pricing is typically lower for the members. If your company, SpaceX, has a corporate semi-membership, yeah, that's the way to do it and save money. I'm sure they do. They have to. I'll ask about that when I get there, though. I'm like, hey, do we have a membership with the semiconductor equipment manufacturing industry? And they'll be like, yeah, maybe. I'm like, well, we need to get one because I need these books because this is important. All right, so cool. Good to know. All right, so hi, Obadiah. Now I have to go pee. Got so excited about this stuff. I got all this nervous pee. I'm like, I gotta go. My bladders. Oh, it smells so good. I cleaned the toilet. Well, like in the whole area, the floor, the sides, the inside, everything smells like cleaning stuff in the bathroom now. Pine sol and bleach. Probably a real good concoction for poisoning yourself. But it smells good in here now. Go to the bathroom. Nice. Okay, back to the office. Or as Flurg would say, the studio. I'm going to go to the studio. I'm the Amish vampire. I'm going to the studio. Okay, so how long have we been going? Jeez, it's almost an hour. All right, so we got distracted. We started talking about this semiconductors, ultra-pure resistivities. We talked about that. There we go. We got to this part, defined by the semi F63 standards. And then we said, all right, let's all go and learn about what is this semi F63 standard. And then that's where we got all of this information right here. And we learned all about that stuff and learned about that you have to buy them. They're not free. You got to go purchase them, blah, blah, blah. All right, cool. Oops, wrong thing. So these specifications apply to semiconductor facilities and manufacturing devices with line widths of 32 nanometers and smaller. Let me ask. On the Bastrop, Texas Starlink fab, what is the nanometer size of the line? Hopefully he understands what I'm talking about. They're talking down to like 2 and 3 nanometers and under 7 nanometers, and you have different requirements. The Bastrop does not have its own semiconductor water fabrication line with a specific nanometer processing node. It is primarily a satellite and terminal manufacturing plant, largest in North America for Starlink user terminals and dishes, combined with semiconductor advanced packaging, back-end processing, research and development, printed circuit boards, the PCB. Printed circuit board is what PCB is. So that's something it's an acronym that we'll have to deal with out in the world. And panel level packaging, fan out panel level packaging. The facility takes prefabricated silicone dies or chips. So we don't make the chips there. They come in. They're prefabricated from wherever we get them from. At other foundries and performs the packaging, assembly, testing, integration into radiation hardened modules for Starlink satellites and user terminals. So the user terminal, like if you say, hey, I want Starlink, and they send you the dish and this and that, the hookup thing, that is your user terminal. We make those there. Also, the satellites we make there. So we integrate the chips and the boards and all that stuff into a radiation hardened module, so that it can be out in space and not get cooked for the Starlink satellites. There is no front end wafer fab. The part that actually etches transistors at a specific nanometer node. Okay, cool. This is good to know. Operates there currently. I think they're going to, I don't know, but not currently. We're getting the parts from elsewhere. wafer fabrication for advanced nodes happens at partnered foundries, the TSMC, Samsung, and other larger planned terafab projects, or the planned. This is terafab. This is a facility where we're going to make our own wafers, make our own chips. So, like when we first started, we didn't make our own solar panels. We just got like a Samsung solar panel that got shipped to you with the satellite receiver, right? Now they're making this huge thing. All right, Bastrop, Texas map. All right, so right here it is. Here's the parking lot. All right, so now, right now, and this whole area, see where my mouse is moving? This whole area, there's like a 4-story monster warehouse going in right here. Actually, it starts like back here. It's back away from the road a little bit. It goes like, boom, it's massive. And that they're going to be making their own solar panels that go with the Starlink system. And so in the future, they're going to also be making their own wafers, making their own chips, so it's very much, we just make everything, all the components. If something goes wrong with Samsung, we're not going to care anymore because now we make it ourselves. So that's the idea. And so now they're making the big solar panel fabricating facility, which of course is going to also need people like what I'm doing, ultra pure water, a whole facility over there. And maybe by the time they get done over there, I can move over there and be in charge over there. And then and this is the boring company here, where they make. Let me show you what the boring company is. The boring company. They make tunnels. They dig tunnels. There's Elon with his flamethrower.
Geez, Dell, why are we thinking about work? All you need to do is go to robertspaceindustries.com and send a captain's level org invite to @MuskieOverlord, all one word. Okay.
And
Bio
Muskie
7.
Overlord. Hey. Sorry, I had to clip that one. Goober. So anyway, this is a giant, like 20-foot around cylinder that turns and then bores a hole through it underneath the river, through a mountain, all that kind of stuff. They're going to need that also for when they start making facilities on Mars and on the moon. You're going to be drilling tunnels and making facilities underground on the moon or on Mars. Why have it be up on the surface where it gets solar radiation beating into it and high winds and sand and debris wearing it out, and you got to worry about windows getting cracked? No, just build it underground. Bore it underground, plascrete seal the walls, airtight. Bam. Everything is going to be underground. That's my prediction anyway. It'd be stupid not to. And I don't know, what is this facility over here? I never paid attention. Snail broke. What is this? Housing complex. All right, let's take a look. I don't remember that. I was focused on turning into the parking lot and parking. This is the parking for the facility. And then this is the very corner is where the lobby is. But yeah, this whole area, right? Oh, it looks like they started. They're moving these electrical lines because this is where the big factory is now. It's enormous. It's enormous. Oh, wow, this is an old picture because this is the guard shack. This whole area over here is more parking. And then this is more parking. But yeah. So this is a pretty old picture because this is like there's several hundred cars can park here. And then where those trees are, that's where the factory is. All right, so what's going on over here? Oh, this is the boring company there. Well, what? I'm confused a little bit. I can't move? I can't move, I guess. This is as far as I can go. Look at that. It's kind of some kind of water truck. You see that? Got a little, what's that say? I can't tell what it says. Center point. Prep, perp, Jeep. I don't know what. I don't know. I can't read blur. I don't have a blur reading skill. See, I just can't move further down this road. Whoa, what's that? Is that a police car? I don't know what that is. Okay, anyway, there, the boring company. See? All right, distracted. All right, back to the training. So, oh, then I got to hear it. I wanted to know about its size. A Starlink facility works on an advanced nodes. It works with advanced nodes, typically 3 nanometers, 5 nanometers, 7 nanometer range, for the silica dyes supplied to Bastrop for packaging. All right. So those dyes we're putting, we do the wafers. I know we do the wafers. And then we're applying the supplied chips, the silicone dyes that are these tiny, 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 tiny sizes. So that's why we need the ultra pure, like super, super ultra pure. So that makes sense. And at some point, we're going to be making our own chips down into these sizes. So good. These are selected based on performance, power, and radiation tolerances for space applications. A much larger dedicated wafer fab called TerraFab has been filed for in Texas, separate but related to the Bastrop operations. But details on this exact process node are not publicly confirmed yet. Yeah, I can't say nothing either. I was going to say something, but I'm like, yeah, actually, I can't. It is expected to focus initially on RF and ASIC chips. You know what RF chips are? Like in your wallet, your the chip that's in your credit card that you just swipe. That's an RF chip. If you're asking on the context of the ultra pure water wastewater role in the Bastrop site, the water purity requirements that are driven by the packaging and the PCB processes. But again, PCB is control board, process control board. What does PCB stand for again? I thought it was process control board. I hate acronyms so bad. Printed circuit board. So packaging and printed circuit board processes rather than when sharing your information with me from now on, and it uses an acronym. Please also include the full name of what the acronym means in parentheses after the acronym. I spelled it wrong. Acronym. Oh, look at the last time when I gave up, I actually spelled it right. I'm like, that's enough letters, and I just stopped typing. Now on, when I use an acronym in response to you, I'll include the full name in parentheses right after it, like UPW ultra water. There we go. If you have any other questions about the Bastrop, Texas Starlink facility, semiconductor yes. See, he's now Grok is tuning its answers to my proclivities. A much if you are asking in the context of the ultra pure water wastewater role and the Bastrop site, the water purity requirements that are driven by the packaging and the PCB printed circuit board processes rather than the full wafer fab lithography. let me know and I'll be more specific. I am referring to the ultra pure water and waste water role at the Bastrop site and what levels of water purity are required for that facility. I want to see if it does an acronym and then does what I said and remembers. Oh, it totally did. Yes. Yes. This is really good. All right. So it says at the Starlink Bastrop, Texas facility, the ultra pure UPW, ultra pure water requirements are specified as greater than 18 micro or mega ohms per centimeter. See, that's the way. Yes, that's acceptable. So, key details. This level, greater than 18. Oh, dang it. It didn't do it there, though. Is the standard benchmark for high purity, ultra pure water. Oh, you know what? I didn't have breakfast. I'm like, why am I so hungry? You got to feed yourself, Delnorin. Die. It is very close to the theoretical maximum resistivity of pure water of an 18.2 mega ohm per centimeter at 25 degrees Celsius, meaning the system must remove nearly all ions. The Bastrop site uses ultra pure water. See, UPW, it did what I said. Across multiple manufacturing processes, including PCB. In the last response, you used the term PCB and did not include the parentheses after it explaining what the acronym means. Please modify your response above to include this and others where you forgot to follow my instructions in this request. Include in above to include. All right, and enter. So it should give me the same exact response, but include what that acronym meant. Here, all right. Here is the corrected version of my previous response. Properly expanded per your instructions. All right. See, I did it right there. PCB, printed circuit board, pretty good there. Is very close to the theoretical maximum. Mega ohms, that's good. The Bastrop site uses ultra pure water, including a PC. All right, so now it's following my instructions. Printed circuit board fabrication, panel level packaging, cleaning, rinsing steps, and component assembly. It also generates significant complex wastewater streams, greater than 10,000 gallons per day, referenced in some postings. So that more than 10,000 gallons a day is what we take. We remove all of the heavy metals, the copper, everything from the line that was created using our ultra pure water, rinsed off. All those contaminants get in the water. It creates 10,000 gallons per day or more, and then we pull all those heavy metals out and then bring it back. You reuse all of that water, treat it all, and then put it back through and make it ultra pure again, and then they reuse it. How this compares to full semiconductor wafer fabs. In full leading edge wafer fabs, those running 3 nanometers to 7 nanometers processes, semiconductor equipment and material. See how it's doing it? Instead of just saying semi F63, now it's giving me what the acronyms mean. This is way more Delnorin friendly. Way better. Thank you, Grok. Typically requires not only more than 18.2 mega ohms per centimeter resistivity, but also extremely tight controls on total organic carbons, less than or equal to 1 part per billion. Thank you. This is so much better. I just need like automatic, like in my ear, my brain just translates acronyms, or just people just stop using acronyms. How about that? Particles, very low counts of sub 50 nm nanometer sizes. Specific metals and ions, often ppt, parts per trillion levels, and silica and bacteria, etc. Bastrop's requirements are high, but focused on the packaging, printer circuit board side, so they emphasize reliability, high volume ultra pure water production, and robust wastewater treatment for chemicals and byproducts from plating, etching, cleaning, and assembly processes. It is not as a front end wafer fabrication. See, it says fab there. I don't like that. It's good enough. Your role as ultra pure water and wastewater specialist, this is my job, will likely involve, oh, this is cool, operating and maintaining systems like reverse osmosis, EDI, or electronic deionizations, UV, ultraviolet, disinfection, ion exchange, and final polishing to consistently hit greater than 18 mega ohms per centimeter. Monitoring with tools like Hawk analyzers or similar for resistivity, total organic carbon, and particles. Managing wastewater treatment to meet Environmental Protection Agency and local permits handling complex streams from manufacturing. If you have access to internal SpaceX specs, well, I wouldn't be able to share it with you if I did. Standard operating procedures, which that's another thing I'm going to do when I get there, is make sure they have these in place. And if not, start making them. Like, hey, this is the water, every process, be able to like have a laminated sheet of like 4 pages that's just hanging on the equipment, and they can just look through it at any time and go, here's pictures, there's this, there's that. This is if this does this, then you go to step 4. This is how you do it. So anybody can walk in there and then really quickly be brought up to speed and taught how to trace where this goes to that goes to that. This is the levels that need to be on here before it goes into there. Everything needs to be like just super easy, and so that you don't have compartmentalization of information. People used to do that. I'm not going to tell you how I fixed that, because if I told you that, then you can replace me. That's not the way of the world anymore. That's a good way that they're going to say goodbye to you. Oh, that was the thing. I just saw a thing. A gentleman was being interviewed about Elon, and Elon's I think I shared this. It was fascinating. I just loved it. I think I commented on it, so I should be able to find it pretty quick. His mindset. This is it. This is it.
I think that people appreciate how you. I would say definitely Elon runs his company in an extremely unique style. I don't actually think that people appreciate how unique it is. You sort of like even read about it and so much, you don't understand it, I think. It's like even hard to describe. I don't even know where to start. But, well, number one is like, so he likes very small, strong, highly technical teams. I would say at companies by default, the teams grow and they get large. Elon was always like a force against growth. I would have to work and expend effort to hire people. I would have to like basically plead to hire people. And then the other thing is that big companies, it's really hard to get rid of low performers. And I think Elon is very friendly to, by default, getting rid of low performers. So I actually had to fight for people to keep them on the team because he would by default want to remove people. So keep a small, strong, highly technical team. No middle management that is kind of like non-technical for sure. So that's number one. Number two is kind of like the vibes of how everything runs and how it feels when he sort of like walks into the office. He wants it to be a vibrant place. People are walking around, they're pacing around, they're working on exciting stuff. they're charting something, they're coding. He doesn't like stagnation. He doesn't like for it to look that way. He doesn't like large meetings. He always encourages
love
people
this.
to like leave meetings if they're not being useful. So
Leave the
actually we
meeting.
see this
If you feel like you're sitting in the
it's a lot-
meeting and you're like, I'm just wasting my time, get up and leave. And that's not like you're not being rude. That's just the culture. You're like, all right, I'm not important here anymore. I'm out of here. I'm not learning nothing. I'm not contributing. I'm gone.
large meeting, and if you're not contributing and you're not learning, just walk out. And this is like fully encouraged. And I think this is something that you don't normally see. I think a lot of bigger companies, they like pamper employees. I think like there's much less of that. The culture of it is you're there to do your best technical work.
Oh, I love this.
There's the intensity and so on. And I think maybe the last one that is very unique and very interesting and very strange is just how connected he is to the team. So usually a CEO of a company is like a remote person 5 layers up who talks to their VPs, who talk to their reports and directors, and eventually you talk to your manager. That's not how your companies, right? Like he will come to the office, he will talk to the engineers. Normally people spend like 99% of the time maybe talking to the VPs. He spends maybe 50% of the time, and he just wants to talk to the engineers. So if the team is small and strong, then engineers and the code are the source of truth. And so they have the source of truth, not some manager.
Yes.
To understand the actual state of things.
This is so good.
To improve it. And also just like his large hammer and his willingness to exercise it within the organization. So maybe if he talks to the engineers and they bring up that, what's blocking you? Okay, I don't have enough GPUs to run my thing. And he's like, oh, okay. And if he hears that twice, he's gonna be like, okay, this is a problem. So like, what is our timeline? And when you don't have satisfying answers, he's like, okay, I want to talk to the person in charge of the GPU cluster. And like someone dials the phone and he's just like, okay, double the cluster right now. Like, let's have a meeting tomorrow. From now on, send me daily updates until the cluster is twice the size. And then they kind of like push back and they're like, okay, well, we have this procurement set up, we have this timeline, and NVIDIA says that we don't have enough GPUs and it will take 6 months or something. And then you get a rise of an eyebrow. And then he's like, okay, I want to talk to Jensen. And then he just kind of like removes bottlenecks. So I think the extent to which he's like extremely involved and removes bottlenecks and
so good.
I think is also like not appreciated.
This is the opposite of any city job I've ever had.
That are very unique, I would say, and very interesting. And honestly, like going to a normal company outside of that, you definitely miss aspects of that. Maybe that's a long rant. I don't think I hit on all the points, but it is a very unique thing, and it's very interesting.
Oh, I'm so stoked, guys. I am so stoked. All right. If you have access to the specs and SOPs, I started to explain SOPs and how the importance of making it a simple thing and not guarding the information to protect your job, but excel, coming up with new ideas, coming up with the questions and go, well, why? Why is this the standard? Why can't we make this better? Why is this the way it is? Why can't we make that better? How do we make that better? What's stopping us from making this better? This is why they want, this is how they select who they want in the company. The people that are not satisfied with, okay, I'm just going to sit here, put my feet up on the desk, and as long as there's no alarms, I'm doing good. No, they want you to like figure out how to make it better. Oh, I'm so stoked. Or the detailed system design documents. Those would give you exact target parameters. So I could feed that into Grok. I'm wondering, with the NDI, the non-disclosure agreements and stuff I have to sign or have signed, can I feed that info into Grok to help me do better? Because Grok is owned by Elon. I'd have to ask, like, Elon, yeah, I know there's an NDA, but Grok is helping me open my mind to different options, and he's bottlenecked now because I can't give him our SOPs to help me figure out how to make better processes. He'll be like, "Yep, you can do it. Don't share it with another human being or another AI, or I'll have my people make sure that there's a giant firewall around Delnorin's thing so that info can't get out." That'd be cool. Maybe that's what because he's gonna stop by. He walks through places and talks to people and starts asking people. He'll be like, "You, what do you do here? What how is it going?" How can you make it better? You know, what do I need to make you do a better job? What can I give you? What can I help you with? What can I help you understand? What things can I remove from that's blocking you from doing a better job? He has those conversations as he's walking around. So at some point he's going to come up to me and say, I'll be like, yes, NDA. I want to share stuff here with Grok because Grok is helping me do stuff, and he's being bottlenecked and stopped because of the NDA. Can you allow me to share things with Grok, only Grok, not with anybody else, not the results that Grok gives me with anybody else, just to help me do a better job here? Do you need to put up special firewalls on my account in such a way that it can't leak out? You know, the greater Grok mind or something. I don't know. But I can see that, I mean, like, I get a chance to talk with them, and I'm like, yes, I need your permission to use Grok. All right, specific total organic compound limits, particle counts. So yeah, Grok wants me to give him very location-specific data so he can help me more. Would you like me to compare the typical materials tables, suggest common monitoring practices, and to use yes on all the questions in that last paragraph. Comparison of bastrop requirements to typical semiconductor equipment and material international F63 tables. Parameters for advanced semiconductor manufacturing, the resistivity greater than 18.2, TOC removal less than 1 part per billion for total organic compounds, particles less than 1 particle per milliliter, silica less than 0.3 to 1 part per billion of total and dissolved silica. Metals and ions, very low, 0.01 to 0.005 part per billion, 0.005 part per billion. Zoinkies! Or part per trillions per metals for things like sodium, iron, and copper. See, I didn't tell. It's not an acronym, I guess. That's a chemical symbol. Also, in the future, things like Na, Fe, Cu, Cu for sodium, iron, and copper. Please include, as you do with acronyms, the chemical element in parentheses after each element. Please redo the response above with this in mind. I'm making Grok like super Delnorin friendly. All right, so there it is again. But now, where it comes down here to, yep, sodium, iron, copper, etc. Nice. Key differences. Man, that is sweet. Bastrop focused on advanced packaging, printed circuit boards. So earlier today, it would have said PCB, and it would have annoyed me. Now it says printed circuit boards. Now I'm burning into my head when somebody says PCB. I'm going to see this in my head. Printed circuit board. I'm visually burning this image into my brain every time I read it now. So when I hear them say PCB, I'm seeing printed circuit board. Printed circuit board. Printed circuit board. And there's no reason you just say printed circuit board. Nobody has to memorize this crap. Anyway, and assembly operates at a high but not full wafer fab stringency level. Fabrication. When using industrial terms like fab or fabrication also include in parentheses the full word, like fabrication, from now on. Please redo the response above with this in mind. All right, a bunch of finger mash in here. Type that. The response above with this in mind. He's gonna be like, man, you're picky, Delnorin. Okay. Particle resistivity, what do we got here? Depending on the grade, Bastrop's likely aims for similar low levels, though exact internal targets may be adjusted for packaging of printed circuit board needs. Particles, less than 1 particle per milliliter for greater than or equal to 0.05 micrometers, or even tighter, sub 20 nanometers in leading edge fabs, fabrication. Packaging processes are sensitive, but typically less stringent than wafer lithography. Silica, less than, all right, we did that. Total dissolved. Metals and ions, we did that. It's sodium, it's how it does the chemical. What's the word? You got your chart of chemicals. Hydrogen's up here, gold's over here. Ions, what's that called again? Element, chemical element. Jeez, my brain broke again. Bacteria, CFU per L. Colony formation units per liter. This is so much better now that Grok is giving me answers with the actual acronyms. Hey, Driz.
I got you tabbed.
Thank you, bud. Key difference. Bastrop's focused on advanced packaging. The printed circuit board fabrications and assembly operates at a high, but not full. All right, am I all the way down? I am. But not full fab or fabrication. There we go. Stringent level. Full wafer fab or fabrication, driving the strictest semiconductor equipment and material international F63 specs. Are more concerned with sub parts per trillion metals and ultra low particles to avoid defects in transistor structures. Bastrop's emphasis is on reliability, high volume, ultra pure water for rinsing, plating, and cleaning steps in the packaging. Common monitoring practices at the ultra water and similar facilities. In electronics, packaging, manufacturing like Bastrop, robust real-time and offline monitoring is essential to prevent contamination excursions that could affect product quality and cause downtime. Typical practices include inline and online monitoring, continuous, resistivity, conductivity sensors, and primary indicators for ionic impurities. TOC, or total organic carbon analyzers, sievers or Hawk, or equivalent membrane conductometric systems for low parts per billion detection, particle counters, and ultraviolet intensity, dissolved oxygen, silica, and pH sensors. Sampling points at the ultra pure water generation skid, distribution loop returns, and critical points of use, POU, points of use. Locations near tools. Offline grab samples, perform lab analysis for metals. So I could take what a grab sample is you open up a valve, pour a little in a beaker, you take it to the lab, run a sample manually. Like, hey, I'm curious about this. Is the probe even reading the pH correct? Let me take a sample and go put it on a bench top. Let me just put a probe in there and check that. All right, it matches. All right, good. The pH probe is good. We can trust the pH probe now. But that's what a grab sample is for, is take a point in time sample. It's not measuring and continuing to measure the flow. It's just I grabbed a bit and I'm going to run a sample. Frequency, continuous and continuous for resistivity, total organic carbon, daily, weekly grabs for metals, particles, alarms for any deviations. So yeah, it goes into the computer. If it gets up too high, an alarm goes off. It's like, oh, go run over there and check that out really quick. Tools, Hawk analyzers. Hawk is the company name that makes a lot of benchtop laboratory equipment. Hawk lab equipment. So all of this kind of stuff is made by Hawk. That's the company. Everything here is Hawk. They make dispensers, they make pH probes, they make everything. If you're in a laboratory somewhere, you're going to see Hawk equipment. Best practices is to maintain excursion-free operation with proactive resin, ultraviolet lamp replacement, and redundant polishing loops. 3, wastewater handling. So this is what I was talking about, the wastewater, how we reuse it. The facility generates complex wastewater from the ultra-pure water production reject streams. The PCB, printed carbon or printed circuit board, etching, plating, acids, metals, and organics, and other manufacturing processes. The key point, ZLD, very important. Zero liquid discharge. You're not wasting any water. You're not putting any water. Yeah, he's not here anymore. He goes to everybody's live stream and says, got you tabbed. And then he goes and does his live stream. He just goes down everybody and says, hey, pay attention to me, which is fine. I don't care. That's cool. And for like the last 3 times, I went to his website and showed everybody him and said, hey, go check him out if you want. But now I see that he just does it to everybody. And it's just his way to spam everyone to get attention. So I've stopped pointing him out. I just like, hey, thank you, bud. And then I just move on. I don't spend time giving him more attention because he's just trying to get free views. Like if I went down through everybody gaming and like, hey, how you doing? I got you tabbed. Hey, how you doing? And it's just cut, paste, cut, paste, cut, paste. Pay attention to me. Pay attention to me. Pay attention to me. And it's kind of lame, but whatever. So zero liquid discharge. Focus. SpaceX postings emphasize advanced treatment, chemical precipitant, clarification, and will the zero liquid discharge. We'll go through in these classes that we're doing here, the training, an entire whole day probably on just that. It's pretty cool, and I need to learn more on that. So that's one of the things I need to go and dive deeper into. Right now, we're still on surface level. We haven't dug super deep into the treatment process. Clarification, membrane filtration, reverse osmosis, electro deionization, ion exchange. That's all the stuff we've talked about before. Evaporators, we'll learn about. Crystallizers, we'll learn about. Solids handling, we'll learn about solids presses and stuff like that. To maximize the reuse and minimize the discharge. Also in the wastewater handling, the partnership with local utilities. SpaceX has agreements with the city of Bastrop and Corix for wastewater transfer and treatment of the city's plant. Services began ramping up in 2026. This handled broader site needs, while on-site systems manage high-strength streams. High chemical oxygen demands, heavy metals, fluorides, solvents, silicas, etc. So I'm sure that SpaceX is giving money to the local wastewater plant to make sure that they can handle what does come out of the factory. There's some. I'm not saying there's not any, but they're going to be investing money. They don't want a PR nightmare of, oh no, there's a bunch of heavy metals being released and it's all because of SpaceX. People are just waiting for some tiny little retard to come up with a comment like that that works at the local newspaper, and then they'll, so you know that SpaceX is like, hey, we're going to make sure that nothing is going to ever be a problem with the wastewater and what's going out into the river or into the lake. So we will help you install and fund or give you even grants or loans and to make sure that you can upgrade so that if something goes bad at the plant, nothing's going to get released to the environment. You know that they're thinking that and they're doing that. Partnership with local utilities, I said that. Regulatory compliance, full adherence to the Environmental Protection Agencies and National Pollutant Discharge Elimination Systems permits, with emphasis on hazardous waste minimization and environmental audits. Your role, or my role, Delnorin's role, will likely include optimizing these systems for reliability, compliance, and water reuse goals. Nice. And that brings us to this location. And I think I'm going to stop for this live stream. All we did was we went from like here, here to here. And we had an hour and a half live stream on just that information and jumping and going, what does this mean? What does that mean? And jumping into Grok and looking up different web pages and learning as we go. So this one article is going to be hours of live streaming. We've only got this much more to go. So tomorrow, when I do a live stream, actually tomorrow's Saturday, I'm going to be spending all day playing a Firefly TV show role-playing game that we made with a guy that I know here locally named, I can't say his real name. He is Octavia. So if you see Octavia Blake in chat, that's him. And so he's going to come over. We're going to play a role-playing game all day from like 8 a.m. to like 6 p.m. So there probably won't be any live streaming tomorrow night or tomorrow at all. So this would be, and I don't know how much on Sunday as well, because I got church and family stuff. So maybe it won't be until Monday. I don't know. But then we got Monday, Tuesday, and then Wednesday I start taking all the monitors down, packing up the computers, getting it all ready to go. Thursday morning at 7 o'clock in the morning, I'll get the U-Haul truck, pull it all up, get it all hooked up. 8 a.m., the movers show up, and they help me pack up the trailer, this big, huge, solid wood desk, all the heavy stuff up into the trailer, packaging it, the blankets, all the monitors, everything packed in there just right. The back of the pickup truck, the bed, the box springs on top of totes and all tied. They're going to help me do all of that. And then the wife is working from home. And then at the end of the day, when we get ready to go, she gets out of work. We'll grab a bite to eat. And then, boom, we start driving 18 plus hours to get to Texas. Because you're only supposed to drive 55 miles an hour maximum with one of those U-Haul trailers behind you. So, so Monday, for sure, we will get back to continuing this training. All right, so I'm going to take a break. I'm going to have breakfast. I'm going to actually, it's noon now. Dang. And then we'll come back and we're going to do another sermon from River Valley Church in Bastrop, Texas. It's going to be our new home church, I believe. I'd have no problems wanting still to go there. I've watched like 4 of their sermons. I read their whole webpage, everything. And they seem very solid. Booyah! So we will be back. We'll watch a sermon. That will be one live stream. You can look back at my other live streams. If you want to click on my, Delnorin logo there, and you can see my previous live streams, you'll notice this one with the building, and it says a big R, and it's like the Riverview Church sermon. So now we'll do like the 5th sermon, and then that'll be one live stream, and then we'll stop. I'll go do stuff around the house that I need to do, and then we'll come back and do another live stream, and that'll be gaming. So training and education, a church sermon, and then a gaming live stream. 3 live streams a day. So we will be back. Oh, wait. I almost tabbed out of this, and I need to stream out to somebody. Hillbilly. Let's go with Hillbilly. He's got nobody watching him. Like literally nobody. Let me turn this up. All right, let me pull out his thing.
Come out of that building yet? Yeah, he's back here.
Ah, shit.
Gas inbound. Safe zone relocated.
Marking hostile.
Attention operators. Classified weapons entering the area soon. Watch the skies.
I broke the armor.
Enemy airstrike.
Precision on me. Cracked the one that was parachuting in. That boy's all the way over here now.
Marking hostile.
Sniper down low. Better aim than that, boy. What's wrong with you?
Those got to be bots. Yeah, that's a bot. I mean, still, it's fun, but yeah, there's a difference between players and bots. That's a player out there.
Better play it before it knocks me, huh?
All right, I'm out of here. I'll be back in a bit. Where's my buddy? My button. My button. My button. Where's my button?
Oh, say, can you see by the dawn's early light what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight over the ramparts we watched were so gallantly streaming, and the rockets' red glare, the bombs bursting in air, gave proof through the night that our flag was still there. Oh, say